absolute value. When looking at the definition, the absolute value of a number x, written like this, x surrounded by these two long bars, that's the absolute value of x. The definition is the distance that the number x is from 0 on the number line. So that sets up an equation where we can say to solve the absolute value of x equals 4, for example. The two solutions are -4 and 4 because each number is 4 units from the origin. That's the distance that number is from 0 on the number line. You can go 4 to the left or 4 to the right. This number line here is the graph of those solutions, -4 and 4. So you can visually see the 4 units from the origin, and it follows then that the absolute value of -4 is equal to the absolute value of 4, which is equal to 4. And we can note by agreement that distances are always non-negative, so absolute value is always going to be non-negative. So here's another example where we have that equation and the directions to solve and graph the solutions to the equation, absolute value of x equals 7. Well, again, the absolute value is our distance away from the origin, so this is asking what number x is 7 units from the origin. Looking at the graph to make the solution, we have that if you go 7 units to the left, a distance of 7 to the left, you arrive at -7. And if you go 7 units to the right, you arrive at +7. So there are 2 points on the number line that are 7 units from the origin, making the solutions -7 and 7. So we can note that the absolute value of -7 is equal to the absolute value of 7, which is 7. Now, when you look at absolute value, you then want to think about the word opposite and think about what that word means. So take a minute and think about the word opposite. Describe it in your own words. Share a few examples with the people around you. Think about things like maybe at first opposite things you know in real life. So maybe you're thinking of hot versus cold, up versus down, wet versus dry. But then you want to think, what does it mean for numbers to be opposites, right? How can you identify opposites? Well, you look at their sign, right? +4, -4, 3, -3, 100, -100. So those are opposites. And then for expressions to be opposites, well, now you go a little further. It's a little bit trickier to just look at their signs. So you want to think truly, what does it mean to be opposite? In previous exercises, the solutions to the absolute value equation, absolute value of x equals d, were opposites. The idea is captured in the statement that the absolute value of opposites are equal. That's what we saw before. So two expressions are opposites if their sum is 0. That's a more exact definition. So it follows that A and B are opposites if and only if A plus B equals 0. And this kind of sets up criteria for opposites. We can just add and find the sum of whatever we're comparing. So if we look at these here, -3 and 3 are opposites. Well, let's see. -3 plus 3 equals 0. So yes, it would be true that they're opposites. Now we have, we have 3 minus 5 and 5 minus 3 are opposites. Well, let's see. We would have to test that 3 minus 5 plus 5 minus 3 equals 0. Well, if we're adding these two, we can add 3 minus 3. This is commutative property. I'm just moving my terms around. And -5 plus 5 all do cancel out to equal 0. So that would be true. So B, it turns out 3 minus 5 and 5 minus 3, the statement of B, are opposites. It's true. Let's look at C. We have 2x minus 9 and 2x plus 9. So let's see, 2x minus 9 plus 2x plus 9, and let's see if that equals 0. Well, 2x plus 2x, if I move my terms around, and negative 9 plus 9. Well, negative 9 plus 9 is 0, but 2x plus 2x is 4x. And 4x does not equal 0, so these are not opposites. C is false. And now let's check D. X minus 3 and 3 minus x, so x minus 3 plus 3 minus x. We're testing if it equals 0. If I move my terms around, x minus x and negative 3 plus 3 equal to 0. So x minus x is 0, negative 3 plus 3 is 0. So yes, D is true as well. So we can just test the sum to see if the numbers are opposites. Let's look at more examples here where now we're looking at the absolute value in the picture. We're looking at absolute value in the statement. So we have E, true or false. And the absolute value of opposites are equal. So if negative 5 and 5 are opposites, then the absolute value is equal of those opposites. Because think about it, the absolute value of negative 5 is 5, and the absolute value of 5 is 5, because 5 and negative 5 are opposites. So E would be true. Here we have the absolute value of 3x equals the absolute value of negative 3x. So 3x and negative 3x are opposites, so this would be true. We have x minus 7 equals 7 minus x. Well, this one's not as sure to see if these are opposites. So let's test if x minus 7 plus 7 minus x equals 0 to see if they're opposites. So x minus x, negative 7 plus 7. X minus x is 0, negative 7 plus 7 is 0, so 0 equals 0 means they are opposites. So their absolute values must be equal. So G is true as well. Let's look at H. Now we have 12 minus x equals 12 plus x. Again, not as easy to see if they're opposites. So we need to test if 12 minus x plus 12 plus x is equal to 0. Well, 12 plus 12 minus x plus x equals 0. Well, negative x plus x equals 0, but 12 plus 12 is 24, and that does not equal 0. So these are not opposites, so the absolute value would not be equal. H is false. Finally, let's test this example. The absolute value of negative 9 minus 2x is equal to the absolute value of 2x plus 9. Well, let's see if these are opposites. So that would mean that negative 9 minus 2x plus 2x plus 9 would equal 0 if they were opposites. Well, negative 9 plus 9 and negative 2x plus 2x equals 0. Well, negative 9 plus 9 is 0. Negative 2x plus 2x is 0. 0 equals 0 is true. So these are opposite expressions, so their absolute value is indeed equal, making that true. So testing that property is testing if the inside of the absolute value is truly opposites. Some other properties we have are where the absolute value of a product is equal to the absolute value of each factor, the product of each factor. Then we have the absolute value of a constant. For example, 2 times a variable, you can pull out that factor, you can pull out that constant, you can pull it out of the absolute value. And then we have the absolute value of a minus b is equal to the absolute value of b minus a. So let's see if any of these follow that pattern. So the absolute value of 5a equals 5 times the absolute value of a is matching this second property here with our constant coming out of the absolute value, so that is true. Then we have b, the absolute value of xy equals the absolute value of x times the absolute value of y. That's literally the first property, but with different variables, so that's true. Then we have the absolute value of x times y is equal to x times y. That one is not one of the properties. This is a variable coming out of the absolute value, and in our property, it would be a constant, so that is false. We can't be sure what the value of x is, so we can't say it's true. So C is false. We have the absolute value of 12 minus 2x is equal to 2 times the absolute value of 6 minus x. So here, we're seeing if we can take out that factor of 2. Well, 12 minus 2x can be rewritten if we factor out a 2 as 6 minus x. We would have the absolute value of it, and we have it being with a factor of 2 that they're taking out here. So yes, D would be true. Then we have the same property with E, where negative 9 minus 3x is equal to 3 times the absolute value of x plus 3, because negative 9 minus 3x, I can factor out a negative 3, positive 3, plus x, which is the same exact thing if I switch them around to be negative 3 times x plus 3. And if I take their absolute value, I'm taking out a factor of negative 3, but the absolute value of negative 3 is positive 3, making my answer equivalent to 3 times the absolute value of x plus 3, which does match up with the right side. So E would be true as well. It's really just taking what you have on the left and trying to see if you can equal what's on the right using one of our properties. So here is another one to prove that it is true. We can see absolute value of negative 12 minus 6x is equal to 6 times the absolute value of x plus 2. If we look at the left, we're starting with negative 12 minus 6x inside absolute value, which we then are factoring out a negative 6. We're rewriting that inside. Then we're taking the absolute value. We're using the fact that a times b can be the absolute value of a times the absolute value of b. And then we are actually rewriting the negative 6 absolute value as 6. And there is the proof there that the left side is now equal to the right. So again, absolute value properties, you just want to keep in mind the definition and all of these that hold true to see if things are equivalent, if statements or expressions are equivalent.